Let me introduce myself. My name is Medlenggala Anna James. My metric number is 20 DKM 21 F1026. Next is Sylvia Henry with metric number 20 DKM 21 F1014. The next one is Tam Taek Yoon with metric number is 20 DKM 21 F1008. Today I'm going to talk about introductions of the application of differentiation. Differentiation and integration can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions. This is general and most important application of derivative. For example, to check the rate of the change of the volume of a cube with respect to its decreasing size, we can use the derivative from s dy over dx, where dy represents the rate of change of volume of cube and dx represents the change of size of the.
Greetings, my name is Sylvia Henry and my matrix number is 20KM21 F1014. So I'll be continuing with question 1. Stated that find the maximum, minimum, or inflection point and sketch the graph for the question given is y equals to 3x cubed minus 5x squared plus 8. So what are steps needed? So here are steps. So step 1, first, of course, we will have to rewrite the equation given, which is y equals to 3x cubed minus 5x squared plus 8. And then step 2, we will differentiate y in terms of x. So it will be dy over dx equals to, so here 3 multiplied with 3 we will get 9, and then 3 minus 1 we will get x to the power of 2. Moving on to negative 5 multiplied with 2, of course we will get negative 10, and x power of negative 2 minus 1, we will get x to the power of 1. So 8 over here, the x value is actually already 0, so automatically 8 will be 0, which is also will be removed in this equation. So we get dy over dx is equals to 9x squared minus 10x. So step 3, at stationary points, dy over dx is equals to 0, and then we know that dy dx over 0, so we will substitute dy dx with 0. So 9x squared minus 10x is equals to 0. Next, step number 4, we'll find the x values through factorization. So x, we'll bring it out, so we have x in a bracket, and then another bracket is 9x minus 10, close bracket equals to 0. So automatically we will know for the first bracket, x is equals to 0. And the second bracket, 9x minus 10 is equals to 0. So we will move 10, negative 10 to the right hand side, so we'll get positive 10. We will be divided by 9. Multiply will change to over, just to division, so x is equals to 10 over 9. So now that we have the value of x equals to 0 and x equals to 10 over 9, we will substitute this value into the equation y equals to 3x cubed minus 5x squared plus 8, which is the original equation given, so that we can find the y value. So first, y, substitute all of the x with the first x value, which is 0, so that y equals to 3 in bracket 0 to the power of 3 minus 5, 0 in bracket, and then to the power of 2 plus 8, so we get 8 for the first y value. And the second y value, we will substitute x with the second x value, which is x equals to 10 over 9. So y equals to 3 in bracket 10 over 9 to the power of 3 minus 5, also in bracket 10 over 9 to the power of 2 plus 8. So we will get y equals to 1444 over 243. Now that we got the value of x and y, we to be our coordinates. So the stationary points are 0, 8, and 10 over 9 with 1444 over 243. This is the x and y value, and this is also the x and y value. So next, after we have the coordinates, we will need to find the nature of the points by applying second derivative method. So second derivative method is here. So d square y over dx squared, we will differentiate second time, which is 2 over 9, we will get 18, and then 2 minus 1, we will get x to the power of 1, and then x power of 1 times negative 10, we will get negative 10, and x 1 minus 1, well, of course we will get x power 0, so we don't need to write that down. So automatically we will get second differentiation, we will get 18x minus 10. So after we got this value, we will substitute the x equals to 0 and x equals to 10 over 9 into our new equation, which is 18x minus 10. So 18, substitute 10 over 9, x equals to 10 over 9, minus 10, we will get negative 10. So since negative 10 is smaller than 0, that means this is our maximum point. And then next, substitute x with 0. So 18 in bracket 0 minus 10, we will get positive 10. So since positive 10 is basically bigger than 0, thus this will be our minimum point. So therefore, 0, 8 is minimum point, and 10 over 9, 1444 over 243 will be our maximum point. And these are the graphs that we need. Both of these are the point that we find out just now. So graph for y equals to 3x cubed minus 5x squared plus 8. So done. Question number 1.
Okay, in the problem 2, state that given a constant perimeter of a rectangle is 50 cm, the length of the one side of the rectangle is 8 cm, and it's increased at the rate of 0.7 cm per second. Calculate the increasing rate of the area when x equal to 4 cm. So first of all, in step 1, we need to list down all the information in the equation. So as for the equation for the perimeter is p equal to 2s plus 2y, p equal to 50, and then a equal to xy, which means that for the area. So dx over dt equal to 0.7 cm per second, and then x equal to 4. Then the question 1, dA over dt, which means the formula is dA over dt equal to dA over dx multiplied by dx over dt. So step number 2, find the y value by substituting x equal to 4 into the y equation. 50 equal to 2 bracket 4 plus 2y. 50 equal to x plus 2y, which means x go to the other side equal to 42. And then divide by 2, so equal to 21. Y equal to 21. So step number 3, differentiate the formula of area. A equal to xy. So differentiate then x power 1, which means multiply by 1 equal to 1, and then x power 1 minus 1 equal to 0. So theoretically it's equal to 1. So it's equal to y. 1 multiplied by y. So dA over dx equal to y. But by the way, we already found the y equal to 21, so substitute in, so remember that. So step number 4, find the dA over dt. Using the formula as I stated just now, all you need to do is just substitute the dA over dx equal to 21 into there, dx over dt equal to 0.7, put there, and then 21 multiplied by 0.7 equal to 14 over 7 cm per second. So finally the answer is the rate of change of the area of the rectangle increased at the rate of 14.7 cm per second. So that's all from me. Thank you.
Well, this brings to the end of our presentation. Differentiation is nothing but calculating rate at which a quantity change. It's basically the solve of curve of the particular function. For all such example of the real life, differentiation is a method to calculate required values at certain points other than the ones easily. measured or calculated. Most common use of derivative is finding maximum and minimum values of a function. One might wish to calculate maximum profit, minimum loss for his business. Simulation software in engineering highly really opens differential equations to solve difficult geometries. Various problem of nuclear decay, heat transfer, structural analysis involve differentiations. That's all for our present. Thank you.